So a problem I have with what I've been discussing before, and one of the major hurdles with this is, especially in more rural places, is safety and installation. Because you have to install these panels above the ground, then there's a ton of electrical work, which can be unsafe. And for the more centered in an agriculture, an industrialized place, the easier it is for it. But in the middle of nowhere, it can be quite hard, and especially in a less developed country. So is there any good way around that? Well, you could make a package that theoretically could handle almost everything on its own. And I mean almost everything. But the problem is, if something goes wrong, a person is zapped by a bunch of volts, or you start a fire or something. Now, how would I solve this huge problem? Well, one thing is that we've gotten better and better at switches to turn things on and off. And how switches work is that a switch, normally you think is just you bring two metal pieces close together and they conduct more electricity. Well, that's the simplest switch, and it works fine in most cases. But it cannot handle a ton of electricity, and even household switches can't, because when you have two metal plates come closer and closer, eventually there starts to be arcs forming, and this heats it up and can vaporize air, turns plasma, and corrode the contacts until it hits together, and then when it hits it together, the problem gets resolved because the electricity flows away smoothly. The way around this is that most places, they have the two metal plates, and the two metal plates don't contact it, like in ones you see, and this is done using a household. Instead, you have a metal plate that swings in between, and because it's swinging between two other metal plates, it closes the gap twice as fast because it's closing the gap from two sides. Now, you can also have stuff with spring load and stuff, so it brings the plates close together, or there's a sudden clip or snap that puts stuff together faster, so it's less of that time that it's arcing and discharging. Another way that's been done is that instead of bringing one piece of metal in between, you bring in multiple pieces of metal in between it fast, and you have mobile connections, so you have like alternating plates, and you have a bunch of metal plates that can keep going in between it. This is for turning it on fast, and you can also theoretically turn it off fast. But if you have a really source of electricity current, which is something you can detect now better and better, which can show you if something's getting electrocuted actually, you can detect that really fast nowadays, or if there's a fire or a spark anywhere, you can detect those fluctuations really fast, you want to turn it off, and this isn't fast enough. So what they have done is, instead, they can now spray chemical gases that break down really quickly and can turn off the whole thing really fast. A number one of them is sulfur hexafluoride, which can really break down and stop the conduction really fast. And it's sprayed in high temperature, and can do it in nanoseconds sometimes, and turn off high voltage. All these technologies have been useful. But another thing to do that we could do to help it is remote sensing. And the remote sensing aspects could be very different. Could be, you can sense somewhat how much of a current is going through a wire, using that any electricity causes a slight magnetic field. So you can sense a little bit of electricity going without actually touching it. And then you would have to connect all these things together and make a system that you can remotely turn on when the guy is far enough away that it's safe, and that before that, there's not a lot of electricity, and you have mobile switches and mobile places, so nowhere there's too much electricity to really electrocute or hurt someone. And just one by one they turn on, and they check the systems one by one. And if there's a problem, they turn off. Then you have to make the installation and all the plugs really fit together well, so it's foolproof. By doing this, you could also make a modular one. You could make one that could only power home in a rural place in, let's say, a part of the world that is not actually electricity or grid infrastructure, or you can make one that houses up a whole city or more farther away. But you would have to really take the time to design each piece and figure out how they fit together. Now, once the flow comes through, you can slowly switch off to using less of these switches, which will be more efficient, less electric loss throughout the whole entire system. Now, my major concern is expense with all these electrical components, and that expense part is a huge one. But I think it would rapidly go down with manufacturing technology, because it's nowhere near the complexity of building a car, or the materials are nowhere near as like impractical or expensive as like computer electronics or all these other electronics. It's more just really rapidly switching metal bars, some magnets, and sulfur hexafluoride is pretty cheap, but you really have to have a dedicated manufacturing facility. Or you would have to have a way of manufacturing cheaply without a dedicated facility, maybe metal 3D printing. That also tends to be very expensive. Besides this, to make the technology more practical for in-person installation, you could look at another large variety of things, such as how you have to install the grids and stuff that are actually holding up the solar panels, stuff off the ground and stuff, which you can look at using levers and pulleys to pull up stuff, or you install on the ground and you pull it up. But you might need to design pile drivers, something to take stuff from the ground that are more portable, maybe loaned out. But pile drivers and these other mechanical tools, ways you could do it is you could make them into farming equipment, so people could use them also for farming equipment, lowering the cost. Or you could have some kind of loan program going on, some kind of really good loan program going on. Or besides a loan program going on, and besides it being used for multi-uses, you could also have it being disassembled, and you can use some different parts, so you could quickly assemble a pile driver and take it apart. The problem with a pile driver and all these more fancy ones is you might have to actually make them gas-powered if you want to really hit rural areas that don't already have electricity to power them, or you might need to have a temporary setup to power them, and batteries and systems. Another way is in places where there's not battery storage or stuff, or other storage, you'd have to figure out how to store the electricity, and you can use it to power LED lights and stuff that I've discussed to make the plants go more efficient, but there's a way to some extent that's going to get wasted. You could try to figure out how to maybe water filtration and use a lot of that energy just to filter out water nearby. You could try to make cheap pump storage, but it's not the most efficient, but people could more easily make it. And pump storage is when you pump up water to store the electricity, and then you use a hydroelectric to power later. Other things you could do is water filtration to clean the water, which can use up a lot of electricity, and you can excessively clean up lakes and rivers, which will make the whole community healthier. Maybe not as efficient as just cleaning up the drinking water, or bathing water that just use. And you can think of putting other high ones, or you can try to start making more electric vehicles for them, like electric tractors or stuff like that, to store the electricity. And you can look at cheaper battery technology for more remote places. These are all ideas I have to make it more doable for at-home construction. Another one would be to look at very specific places and try to figure out in specific places. You could also design more courses to teach people in villages and stuff how to do it. So then they have to wear like a certification course, and that they train 1 or 2 people to do it, and those people train everyone else come over. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watts hours, which is really hard, but with your help, I think it can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave in the comment section below. Thank you very much again. Goodbye.